Okay, Pre-Calc 12, let's get after it. We are taking all of the information that we gathered and we're going to put it together into word problems. Now, these can be quite lengthy, so I want you to bear with me here. I might have to erase as we go and make more room, and drawings are going to be helpful. I'm also going to take a few steps for granted, so check back into them if something I've done you're a little hazy on. So here we go. A box is constructed such that the length is twice the width and the height is 2 centimeters longer than the width. So let's just think about what this box looks like for a second. If we have a box and it's 3D, okay, the height is everything's given with respect to the width. So the width is the width, the length is 2 times the width, and the height is 2 centimeters more than the width. So those are your 3 dimensions, and they're given with respect to width. The volume you're given is 350. And remember, the volume is length times width times height. So that's where we get our our polynomial from. So our volume, 350, is going to be equal to 2w times w plus 2, length times width times height. So we get 2w cubed plus 4w squared. Okay, and then that equals 350. So we got to get this equal to 0. So 2w cubed plus 4w squared minus 350 equals 0. Now here's a part that I'm going to take for granted in the video, but now divide everything by 2, because that allows us to get just a more simplified version of our polynomial, because so it limits the potential roots. So rational root theorem is going to give us plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 25, 35, and 175. We don't need to consider negatives because width is a length, right? And it can't be a negative value. So you really only got to test your positive values. And you want to just try some. Now, if I tested 1, so we'll just call this polynomial. If I did p of 1, which this is what I'm not going to do on the screen, you end up with a remainder of negative 172. So that doesn't work. But when you do p of 5, you get a remainder of 0. So that's what we're going to use to factor this polynomial. So we have a 1, a 2, remember we have no w value, so a 0, and then a negative 175, and we have a factor of 5. So now we do our synthetic division, and we end up with, as expected, remainder of 0. So we have this factored form. We have x minus 5, or w minus 5, I'll just use x because I wrote it down, and then x squared plus 7x plus 35. Now, there's going to come a moment many times where this portion of our quadratic isn't easily factorable, so we need to remember that we can always use the quadratic equation. Now, the quadratic equation, negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to plug that in, and I get negative 7 plus or minus the square root of 7 squared, so 49, minus 4 times 1 times 35. And oftentimes in these questions, what you'll find is you get a discriminant, the value underneath the root symbol, that comes out negative. In this case, we get negative 7 plus or minus the square root of negative 91. And that's not allowed, right? That's a big no-no. So you get no solution from the quadratic equation. So what that does is it leaves us only one answer, x, but remember x is our w in this case. We get w equals 5. So that's our only solution. The width of the box is 5, which means the length is twice that, 10, and the height is 2 plus that, 7. And just like that, you've solved all sides of the box given only one dimension, which was the volume. So there you go. This is going to be one of your general questions. You're going to see stuff like that. Another question here, we got a little vitamin capsule. Okay, so it's a cylinder with 2 half spheres on the tips, right? So it's your basic sort of vitamin capsule. And on the right here, you see I've given you the equations for volume of various shapes. So that's the volume of a sphere. Now remember, we have 2 halves, which means we would have 1/2 of that, but then multiplied by 2, that's still going to be the volume of our sphere. Here is of the 2, half spheres. Here's the volume of our cylinder. And then here is the volume of the whole thing. Now, in the notes here, there's a really, really solid breakdown, but I also want you to get used to tackling this from one other way. And what that other way would be is to work out this volume algebraically first. So let's do that, because there are going to be a few moments in the workbook where I've asked you to solve for the polynomial, but then use DESMOS, because we can't always use the rational root theorem to find our roots. If the roots are not rational, then we can't use it. So this is an example where you could find them using the remainder theorem and the quadratic equation, but instead I'm going to work this out and just tell you to try DESMOS. So if you work out this equation, your total volume given is 108 pi, okay, and that is equal now to 4 over 3 pi x cubed, and in this case x is our radius, that's what we want, and then plus pi x squared times 14 minus 2x. Now, if you notice, you have a common factor of pi in both values and in the solution, so you can just cancel out the pi, and it just makes life a little bit easier. By pi, by pi, by pi. So now what we have is we have 108 equals 4 over 3x cubed plus x squared times 14, water bomb that x squared in, so 14x squared and then minus 2x cubed. Now, ideally, getting rid of fractions is nice. We don't really want to have fractions. If we can avoid it, we're also going to combine these things, right? So we end up with, and we want to get it equal to 0. So we're going to do a lot of things here. We're going to combine my cubes, and we are going to subtract or add, 108 to both sides. No, not subtract, not add. I was right the first time. Subtract. So we end up with 4 thirds minus 2 is the same as 4 thirds minus 6 thirds. So we end up with negative 2 over 3x cubed plus 14x squared minus 108 now equals 0. Get rid of that fraction and get rid of the leading negative 2. So multiply everything here by negative 3 over 2. It's going to cancel out the negative. It's going to cancel out my leading coefficient. You do that, you end up with a polynomial that has no leading term. And why would we do that? Well, we do that because if you are going to use the remainder theorem and the rational root theorem, that's a whole lot easier to find roots of than if you have fractions and negatives. But in our case, what you're going to do now is you're going to take this quadratic, you're going to plug it into DESMOS. And what you're looking for is you're looking for x-intercepts, because those are your roots. Now, when you plug it into DESMOS, you're going to get some solutions. You're going to see it crosses 3 times. You get x equals 3. You get x equals 20.62-ish, and x equals negative 2.62. So those are your solutions. That's what you would get if you factored and used the quadratic equation. And then you got to consider what the heck these mean. So here, this is my radius, and it's 3. That's not too bad. 3 millimeters for radius sounds pretty good. 20 millimeters for radius, that's not possible. If you plug that in this part of the equation, the 14 minus 2x, you're going to end up with a negative value. So goodbye. And then you just can't have a negative value. So goodbye. So the only root that we can actually consider is that one. So x equals 3, which means my radius is 3 millimeters. And again, in the notes package, I worked through this step by step by step, but I did want you to practice this using DESMOS because it's a handy tool as well, and knowing how to interpret DESMOS can be very helpful. So a couple more. Here, I left extra room on the page to do it, but since we went to DESMOS, I'll leave this one. So here we have an open rectangular box. So there's my box that's open, and we've cut a square out of each corner. So we're kind of cutting out a corner there and there. We're cutting out a corner there and there. And we're cutting out a corner there and there. And we're cutting out a corner there and there. So you can fold the flaps up. And what you end up with is you end up with a length of your box of only this chunk, which is you're at 15 minus 2x, because we take x off of here and we take x off of here. You end up with an inner flap here of 12 minus 2x because you take off an x here and you take off an x here. And then the height of your box becomes x because that's how much you've flipped up. So in this, we get a volume, which is now x times 15 minus 2x times 12 minus 2x, and the volume is 112. So now if we FOIL this out and we work this thing through, so FOIL this, multiply everything by x, and then subtract 112, you end up with a polynomial that looks like this. 4x cubed minus 54x squared plus 180x minus 112. And again, if you look at all of these numbers, they're all even, so divide them all by 2 because it just makes using the rational root theorem a little bit easier. And now using rational root theorem, we're looking at our potential roots. So it's, remember, plus or minus the roots of 56 over plus or minus, or the factors of 56 over plus or minus the factors of 2. So in this case, you get quite a lot, but if we just start with the small ones, 1, 2, 4, 7, 8, and then you would keep going. But again, consider that you're talking about a box. If the x gets bigger than 6, you're going to end up with a 0 width, right? This part here becomes 0. So we don't even worry about 7 or 8. The only roots we have to try are 1, 2, and 4, and they can't be negative. So if we plug them through using the remainder theorem, you find that when you do p of 4, you get 0. Great. So from there, we're going to do synthetic division. And we're going to go 2, negative 27, 90, negative 56. Run that through, and you end up with your new quadratic. So you get x minus 4, and then 2x squared minus 19x plus 14. Now again, just for simplicity, let's plug that into the quadratic equation. When you plug that into the quadratic equation, you end up with 19 plus or minus the square root of 249 over 4. So that is your x equals. So you get 2 more solutions. So from here we get 3 solutions. We get x equals 4. That's from this one here. And then when we calculate the quadratic equation result, you get 2 solutions. You get x equals 0.81, and you get x equals 8.69. But again, that's too big. Too big. It's going to give us 0 width, so we reject that one. And there's a little caveat in the question here that says your x value that you cut out has to be greater than 1. So again, we have to reject that one. And then nice, we only get 1 more solution. So x is 4. So we cut 4 out of the box. It means the height is 4. And then we can plug in 15 minus 2 times 4 is 15 minus 8. So we get a value of 7 for our length. And our width is 12 minus 8. So we get 4 for our width as well. So you can solve through like that. This is explained nicely in your notes. So again, tie these 2 things together. But it's all about putting all of our tools together. Algebra to get our polynomial, simplify our polynomial, rational root theorem, remainder theorem, quadratic equation, DESMOS. You got tons of tools here to put this to an actual applied scenario. So that's just an example of 3. There's a ton of practice in your notes, and a lot of them say, please use DESMOS to solve this one, because like I mentioned, sometimes our roots are not rational, so we cannot use the rational root theorem to narrow them down, and really our only option is to use a graphing app, because there is a equation that solves cubics, but it's absurd. Do me a favor and Google it, and you'll be like, okay, DESMOS it is. Thank you so much, and we are going to move on to section 4. See you next time.